Today I want to talk about a strong induction. Many students assume a strong induction is a stronger or different tool comparing ordinary induction. But is it really? Let's find out. First, quick reminder. In ordinary induction, we do these steps. First, base case. We show that a statement is correct for the first value. Usually it is 0 or 1, but not always. 2. Induction hypothesis. We assume the statement is correct for some arbitrary k which is greater than or equal to the base case. And third, inductive step. Now it is time to use induction hypothesis to show the statement is correct for n equal to k plus 1. So it is like climbing a ladder. If you can go to the first rung and from each rung you can go to the next, you can climb forever. In a strong induction, we have the same base case, but the story is a little different for induction hypothesis. Actually, instead of assuming the statement holds for some value k greater than or equal to the base case, we assume the statement is correct for all the values starting from the base case up to k, such that k is an arbitrary value greater than or equal to the base case. And then we use this stronger hypothesis to show that statement holds for n equal to k plus 1. So the difference is only in induction hypothesis. In ordinary induction, we assume the statement is correct for k, and in a strong induction, we assume the statement is correct for 1, 2, 3, all the way to k if we assume base case is 1. Let's show an example. We want to prove that for all the natural numbers greater than or equal to 2, we can write them as multiplication of prime numbers. The base case is n equal to 2, and it is clearly correct because 2 is a prime number, so we can write it as 2. Now in induction hypothesis, we assume that for all numbers starting from 2 up to k, which is an arbitrary number greater or equal to 2, we can write it as multiplication of prime numbers. Now we want to prove that we can write n equal to k plus 1 as multiplication of prime numbers. We have two cases for k plus 1. 1. It is already a prime number, so we are done because we can write it as k plus 1, which is a prime number. If k plus 1 is not a prime number, then it means that there exist two numbers, a and b, greater than 1 and smaller than k plus 1, such that we can write k plus 1 as a times b. Since a and b are both greater than or equal to 2 and also smaller than or equal to k, they actually satisfy the condition in induction hypothesis, and based on induction hypothesis, we can assume that we can write a as multiplication of prime numbers and we can write b as multiplication of prime numbers. So since k plus 1 is equal to a times b, we can write it as all the prime factors of a times all the prime factors of b. Here, we couldn't just assume the statement for k because we needed some information about some values smaller than k. Like a and b can be anything between 2 and k inclusive. So a strong induction is not really more powerful than ordinary induction. In theory, they can prove the same things. But in practice, a strong induction can make our life much easier because it gives us a bigger toolbox. This was a short lesson on a strong induction and comparing it with ordinary induction. If you want to learn more about ordinary induction, I already have a video on my channel. Check it out. If you like to learn more about theory of computer science and computer science in general, subscribe and follow for more videos.